Hello, welcome back. Just a quick announcement. Today will be the last day for our circles unit. So we've almost completed one of our 3 units. So we're doing really well on that. So good job. I had more people turn in the assignments, but still a lot of you guys are missing turning in those assignments. So make sure you are watching the videos and turning in the assignments because after on Friday, I'm going to be looking at who's been turning in the assignments. If you haven't been turning them in, then I'll be calling home and making sure your parents know what's going on. So make sure that we are doing that. So I'm already liking the changes. Another thing is after you finish this assignment, I will post the practice test for you to take tomorrow. So work on today's assignment today, and then tomorrow we'll take a practice test, and I'll use that to gauge how you guys are doing, if there's anything I need to go over again. So the practice test won't be for a grade, but you'll be taking it on Mastery Connect. So if you've taken a test on an iPad before, chances are you were using Mastery Connect. So I will give you guys your tracker codes for each hour depending on what hour you're in, and you'll use your student ID when you sign in, and then you can take the test. So let's go ahead and move right along. So today's just a review of what we talked about yesterday. There are a few new concepts that are also in the assignment that we'll need to make sure that we know how to do because they'll show up on the test, which you guys will take tomorrow as well. So equation of a circle. So we know for this one, the equation of a circle is just going to be x squared plus y squared is equal to r squared, where r squared is the radius squared. So in this case, the equation of the circle, especially when it's centered in the origin, just, we don't have any h and k going on here, is just going to be x squared plus y squared is equal to the radius squared. So on here we can find the radius counting over 1, 2, 3, 4. So 4 squared would be 16. So we'd write the equation of this circle as x squared plus y squared is equal to 4 squared, or even better, x squared plus y squared is equal to 16. I think that's all that I have there. Yeah, so that's how we write the equation of that circle. So we're going to dive into some more points here that we could plot, just knowing what we know about radicals and the Pythagorean theorem. So again, we start out with x squared plus y squared is equal to 16. So we need the sum of 2 coordinates. So when we square them and add them together, it's going to give us 16. So the first one we might look at, I guess we'll look at that one first, is 3. So when we do, for an x value, when we go over to 3, what is the y value going to be? And if we notice, it's not going to be a whole number. It's going to be some decimal, or it's an irrational number. It's actually a radical. So a radical integer in this case. So, well, if we plug that in for 3 for the x, it's going to give us 3 squared plus y squared is equal to 16. When we square that, we get 9. Subtract 9 from 16. Which is going to leave us with 7. So then y squared is equal to 7. So y is equal to the square root of 7. So the coordinate for this one would be 3 and radical 7. Because when we square both those, 3 squared is 9, and radical 7 squared is 7, and 9 plus 7 is equal to 16, which is the number we were looking for. All right, so then can we use that same process to find all the other ones that have an integer, kind of like a linear Diophantine equation, but they're not both integers, but at least one of them is. So what about over here? When x is equal to 0, what does y have to be equal to? Well, that would be square root of 16, which is just 4, right? All right, when x is equal to 1, 1 squared is 1. So that's 1 of the 16. So what's left over? So 15. So the answer would be radical 15. And then on this one we have 2. So when x is equal to 2, what's the y equal to? Well, it's going to be somewhere around 3.5. It's actually 3.46, but it's an irrational number, so we need to use a radical. So 2 squared is 4. So what's left over from the 16 would be 12, so it would be radical 12. And then here we have a 3 in the y component. So notice that this is in the y component. It's going to cross that axis there, or the y is equal to 3 line. So what's the value for x? Well, 3 squared is 9, so it's going to be the same as the radical 7, right? Except now the radical 7 and 3 are switched, right? So both of those are kind of the middle ones. But there's actually one point that we could plot right in between those two. We'll get to that in a second. All right, so then 2. Well, 2 we said was matched up with radical 12. Oops, that's wrong. Let me fix that real quick. Okay, that means this one's probably wrong too. And then 1 is going to be matched up with radical 15. Yeah, that was one from yesterday. Okay, and then 4 we said was matched with 0, because when we have 4 squared is 16, so there's nothing that has to be left over or made up for in the x component. All right, so then can we solve all these other rational or radical integer solutions? So there are some more over here, and there's a pattern that follows, and it's actually kind of cool. So when we square 1 in radical 15, they add up to 16, right? So we're just looking for two things when we square them at 16. So what does 2 pair up with? So radical 2 is going to go with radical 14, because that 2 and 14 is 16, right? Radical 3 is going to go with radical 13. Radical 4, or 2, goes with 12, right? 5, oops, wrong one. 5 is going to go with 11. I guess I'll lock that there. 6 is going to go with 10. And then radical 8 is going to go with radical 8. And that's kind of the middle point, which is this point right here between those two, which would make a 45, 45, 90 right triangle, right? All right, then we had 3 with radical 7, which is just the flipping those two or whatever. So radical 10 is going to go with radical 6, radical 5, radical 4, radical 3, radical 2, radical 1, which is just regular 1, and then 0. So we found all the other missing radical integers solutions, which is pretty cool. And then on the next slide, we'll see that we were only dealing with the first quadrant with positive coordinates. But what happens if we take the 3 radical 7 and we do negative 3 radical 7? Isn't that going to have the exact same radius as the original one? And so therefore it would be a point that's on the circle because it's equidistant from the center. Well, if 3 and radical 7, when we square them, we get 16. The same thing's going to happen when we do negative 3 times radical 7, because negative 3 squared just becomes positive 9, right? Then 7, which would give us 16. Well, the same thing's going to happen. I wonder how many of these I have. Yeah, I got plenty. Over here, I'm not sure if that's the next one I do. No, apparently I do this one. I don't need to make another one. All right, so 3 and negative 7 is also going to have the same components, and it'll work because when we square negative, it becomes positive, and we could do it when both of them are negative, which would be in the fourth quadrant. So all these points, not only the blue one here, can be rotated or can be reflected across the x and the y axis in order to give us the other points. So if we take all those coordinates and we make the x values negative, then we would match them up here. They would still have the same distance from there that we solved in the first one. And if we make all the y quadrants, or all the y coordinates negative, all those also are going to have to be on the circle because they have the exact same distance from the center, so that it's the same radius. And if we make both of them negative, it's kind of like doing a rotation or kind of like a transformation of rotation, but we make both of them negative, all of those are also going to be the exact same distances away from the center, so they're on the circle. I don't know what I'm doing. Okay, moving on. Then the other thing we saw is whenever we move the circle from the center at the origin to a point not on the origin, like at -2, 0, we have to adjust our equation by doing this minus h and minus k, where h and k is the center. So on this one, because our center is at -2, 0, we would change the h to be -2. So minus and negative becomes plus 2 squared. So x plus 2 squared plus y plus minus 0 squared, because k was 0 in this case because there was no change in the y, which is still equal to the radius squared of 2 squared, which is 4. All right, so why does that work? And we can double check it whenever we look for the roots. So the roots of an equation are where it crosses the x-axis. So that's where the y values are equal to 0. So when I plug in 0 for y, I'm left with the additive identity, so it just goes away, right? Because anything plus 0 is anything. Then we want to know what two values of x, when I add 2 to it and square it, gives me 4. So in other words, I want this value to be 2 or -2, because there's two possible solutions that when I square it becomes a positive 4. So how do I make this value be equal to positive 2? Well, that happens when x is equal to 0, right? Because 0 plus 2 is 2 squared, is 4, so that would work. So then the other thing is this could be a -2, because -2 squared is still positive 4. So what do I add to 2 to get it to a -2? Well, that would be -4. So -4 plus 2 is going to be -2, which when I square that gives me 4 again. Okay, so those are the two roots, which is at 0 and -4. And sure enough, that's where this one crosses the x-axis when it's being offset by 2. So when I move it to the left 2, then the x component is going to be x plus 2, and that shifts everything over to the left too, which is a little counterintuitive to what you think it would do, but that's how it works. So it's x minus h squared plus y minus k squared, and that's the equation for the circle. All right, so the midpoint formula helps us when we have endpoints of a diameter find the center point. So this point is 1, 1, and here we have 6, 4. So to find the center point, we're going to find the average of the x's. So 1 plus 6 is 7, half of that is 3.5. And then the average of the y's is going to be from 1 to 4. So 1 plus 4 is 5, half of that is 2.5. So our center point is going to be 3.5, and I think this one's wrong. Yeah, it should be 2.5. Pretend like you didn't see the other part. Oh no. You know, because it matters. All right, then the only other thing we have left to find, which you already saw, which you just pretend like you didn't know it, is the radius squared. Well, the radius, we can look at components here. See if I can draw straight lines. I'm cheating, so it should work. All right, so how far do I have to go over to go from 3.5 to 6? So that's going to be over 1, 2.5. So 2.5 and then up 1.5. So I want to know what's this distance here, that radius. So I got two values there. I got 2.5 and 1.5. So I can find those by putting it in the calculator. So I'm going to do 2.5 squared plus 1.5 squared, which is going to give me 8.5. And that's what the radius squared is equal to. So that's going to be equal to 8.5. And that's how I find the equation of this circle given to endpoints. So make sure you know how to do that, because you're going to see problems like that on the practice test tomorrow. All right, so that was it. Just 12 minutes for the, then we're right into the assignment, and I talked a little bit about announcements too. So Friday we'll move on to our next unit, which is surface area, and then we'll do volume. So should be pretty smooth sailing from here on out. All right, number 1 says identify the center and the radius of the equation. So they give us the equation, which is x plus 6 squared plus y minus 3 squared is equal to 36. So the first thing we want to find, I guess, is the radius. So the way that we find the radius is by taking the square root of whatever this value is, right? Because that's our r squared. So what's the square root of 36? Well, that's going to be 6, right? Okay, then to find the center, that's the h and the k. So just the opposite of whatever this value is and the opposite of this one as well. So what I want to do is I want to just take the opposite of those two values. So that's going to be minus 6 and positive 3. So our two are going to be minus 6 and positive 3. So the center is at negative 6, positive 3. And we can graph that out. So negative 6, positive 3. And then they said the radius was 6. So to find the radius, a few things we can actually do for that one. Let me just duplicate some points. So from here, just like you did yesterday, if you don't have a compass, is we can just plot a few points and then do our best to draw circles. By the way, your circles look lovely. Some of yours are obviously better than others, but yeah, they all look better than mine, so you guys are doing just fine. And I really appreciate when you guys are trying to draw the circles too. I know some of you were doing it on your phone, and it's challenging enough as is. So we just want to go with a radius of 6 in all 4 of our directions, like cardinal directions. So we're going to go to the right 6. So 1, 2, 3, 4, 5, 6. Okay, and if we're going from negative 6 over 6, that's going to be 0, right? Okay, then we're going to go left 6, which is going to take us all the way to negative 12. And then up 6. Let me lock this in place. All right, then up 6, which is going to go from 3 all the way up to 9. And then down 6, which will take us down to negative 3. Okay, and then from this point, you should be able to draw your circle. I'm going to cheat and use my compass. I bet you want me to try to draw a circle again, don't you? Let me see. All right, I'm going to concentrate as best I can. Oh, that's dope. That is awesome. I'm like a natural at this. Awesome. Okay, well, we're not all equally gifted. It's okay. Let me see how close I was. So that's what it should look like. Good enough. Anyway, whatever you do is fine. So that's number 1. And they should all fit on that same graph, which is kind of cool. So you can do 1 through 4, and they're all going to fit on there. So I made that work out. All right, number 5, write the equation of the circle. So they give you the graph, and you got to find the equation of the circle. So this is just like what you're going to see on the test. So first thing you got to do is find the center. Well, the best way to find the center is find the maximum and the minimum, and then just go halfway between those points. So if I graphed out the maximum and the minimum, you might just be able to visually tell where that is if your spatial reasoning skills are pretty awesome. But if not, you can always just find the average of the y, right? So if we're going from 2 to -6, just add them together, divide by 2. So that's -4, half of -4 is -2. So that has to be our center point, which is at -5, -2. So plug in those values for the h and the k. So it'll be x minus a -5 plus y minus a -2. And then to find our radius squared, we just count over to one of the sides, or count up. So 1, 2, 3, 4. So our radius is 4, so it'll be 4 squared. Now what happens when we subtract a negative? Well, that's going to become plus a positive, right? So if we take away debt, we're actually adding assets. So that's going to be x plus 5 squared and y plus 2 squared, and then 4 squared is 16. All right, number 7. So this is really cool, and I wish we could do this in class together, but this is a way that we can use Thales' theorem to find the center of a circle. So if you already have a circle, you can actually do this whole thing on your own. So like if you want to draw a perfect circle just on a blank sheet of paper, you can get a cup or anything that's perfectly round and then trace it. You can actually try it out on your own. It's kind of cool. And then you just need something that has a right angle on it. So in class, I would hand out note cards, and I'll show you how you can use Thales' theorem. So you can try this on your own. It's actually pretty cool. So take your note card and put the end point of it somewhere on the circle. And then once you've done that, what I want you to do is plot the other 2 points where it intersects the circle. Not what I was trying to do. There we go. So plot the 2 points where it intersects a circle. Now what we've just done here is we've created a right triangle. So if I connect the line from here to here, and from here to here, and here to here, that's going to be a right triangle, right? We know it's a right triangle because we use the note card, which sides are perpendicular to each other, so we know it's going to be a right triangle. So if we have a right triangle, I'm going to move the note card out of the way. So it's kind of what we just did there. It's pretty cool. We have a right triangle. So what does that tell us about this line here? The hypotenuse of that right triangle. So if this is 90 degrees, we know that the angle here has to be 180 degrees, right? Because this is also going to be 180 degrees because it's a central angle, right? The central angle, and our inscribed angle is going to be half of the central angle. So if this is 90, that means this has to be 180 degrees, which means that this has to go through the center. Now, I don't know where on this line the center point is, but I can guess, and I'm actually going to show you how to figure that out in just a second. So what we just did is we found a diameter. So this is a diameter, which means it goes through the center of the circle somewhere. All right, so the next thing I'm going to do is take the note card again, and now just rotate it a little bit. Now I'm going to rotate it till it goes to another point. I'm going to rotate a little bit more because I can. Okay, so put it on where the corner is now on a different point than your original one. And now you can plot again your points where it intersects your circle. So it'll be right here and right here. And then connect the hypotenuse there. And that's going to have to be, again, for the same reason, another diameter, which is pretty cool. So I'm going to change colors just so you can see it in red. But draw that line from here to here. Now where these two diameters, where those two intersect, that has to be the center of the triangle. So you can put a dot there if you want, because where the two diameters intersect has to be the center of the circle. So we can test that with our compass if we have one. If you don't, it's okay. But putting that on the center and then drawing our arc, and if this is truly the center, then our circle should overlap and be exactly the same. Now apparently mine's off by a little bit, but it also, sometimes that has to do with just the compass in general, because this point here is not actually where it pivots from. If you see that, you see how those points are moving in a circle? So it's actually like offset. So if I really want to put it in the center, then I need to put it about right there. I'm testing my theory, and if this works, yeah, that's awesome. Oh, that was better, or maybe it wasn't better. I don't know. So if I took my time, I might be able to get these to work better. And you see my points maybe don't exactly line up on this one or on that one. I didn't really take my time, but I bet if you guys did it, it would be even better. But unfortunately, to be able to test this one, you kind of have to be able to do that last step with the compass, but still, the theory still works absolutely perfectly. It's just limited by our precision, just like whenever we found the circumcenter. Yeah, I think that's what it was called. Yeah, so the centroid. So when we found the centroid of a triangle, we were able to make find the balancing point and spin it, which is pretty cool as well. And it works every time, but it was just limited by how precise you were on your measurements and your construction. All right, so anyway, you can do those or you don't have to do those. It doesn't really matter, but I think those were kind of cool. All right, number 10. So they give us a center of -3, -6. We want to find the tangent to the x-axis. All right, so it's centered at -3, -6. So we can graph that, -3, -6. Now, if we're going to have a circle that's tangent to the x-axis, well, first of all, the x-axis is going to be this line right here, right? So it's going to be tangent to this line. What does it mean for a circle to be tangent to something, or a tangent line with a circle? It means it only intersects a circle in one place, which tells us that the other point that's on this is only going to be in one point on the x-axis. So we need to create a circle that's centered at -3, -6 that goes through this point here, which will be our point of tangency with the x-axis. So it's only going to cross the x-axis one time. All right, so how would we draw that? Well, with our compass, it would look something along the lines of this. But we should be able to write the equation of that circle pretty easily, because we know a point on the circle and the actual the center as well. So if we know the center, that's our h and our k. So we'll do that part first. So that would be x minus -3, which would become +3, and y minus -6 would become +6. Then the only thing we are left with needing to know would be our radius. So to find the radius, you can just count up 2, 3, 4, 5, 6, right? Which is also this component of the point, right? Which is kind of cool. So that's going to be, so x minus -3 squared plus y minus -6 squared is equal to the r squared. So that'll be +3 plus 6 and then 36 because it was 6 squared. All right, so last one I'm going to do with you is number 12. So the center is at -8, 5. So we can graph that out. So -8. That's why I locked these in place. So -8 and then up 5. So that's right there. And the point on the circle is -12, -8. So -12, -8. All right, so that's a point on the circle. So if I want to know the equation of the circle, which I think is what they're asking for, let me go over to the assignment. Yeah, they want us to find the radius, which is one of the things we would do to find the equation of the circle. So to find the radius, I'm going to graph it out, and I'm going to use the components here. So how far do I have to go from the center to go over? I am struggling today. To go over in the x component and in the y component. So it looks like I have to go over 1, 2, 3, 4. So this is 4, and this is up 3. So to find the radius, we're going to do the Pythagorean theorem with 3 squared plus 4 squared, which is going to be 25. Then we take the square root of that, which is a length of 5. So this radius here has to be equal to 5. And that'll be one of your answers. All right, so that's it for today. Make sure you're caught up on your assignments. A lot of you guys still have yet to turn in the assignment from yesterday. So on the assignments, I am going to ask you guys to turn them in now. So let's just start with 10-7. So far I need to see your 10-7 and your 10-8. And then we're going to take the practice test tomorrow, and I'll post later in the evening, I'll post a solution to the practice test. So that you can go through and see which ones you missed. I think that'll be kind of helpful. I'll probably do that going forward next year as well, just so it'll be easier to study because you can actually watch the video and go back to any problems that you want. So I'm already seeing positive changes for next year just by having to do all this stuff. So anyway, good things. I think that's it. Yep, so make sure you turn in your assignments. We'll do a practice test on Thursday, and then Friday we'll move on to our surface area unit, talking about area and perimeter. So it should be pretty easy. All right, I'll see you guys later.